The next part over here, we'll be talking about foot of perpendicular from a point to a line. So typical questions like these, I'll give you a point and I'll also give you a line. From here, I'm supposed to find the foot of perpendicular from a point to a line. So foot of perpendicular essentially it just simply means that if I draw a straight line down from a point to a line, it will hit the right angle at the line there. And that will be the particular coordinate I'm interested to find. So over here, I'm going to give another example before I'm going to let you try the example yourself. The question wants me to find the foot of perpendicular from point P 2, 2, 4 to line direction minus 1, 1 and 2 to plus lambda 1, 2, 2. So if I quickly draw a diagram, now in vectors, remember, it always helps if you quickly draw the diagram itself. So point P, which is 2, 2 and 4, and this is my line, R equal to minus 1, 1 and 2 plus lambda 1, 2 and 2, where lambda is real number. Take note, okay, the question did not define my foot of perpendicular, so I have to define my foot of perpendicular. Okay, so let's say I'm going to define as F. Okay, take note, okay, we are looking at PF and we are looking at the unique part of your line, which is direction. Okay, essentially you should see that it's a right angle from PF and the line. So that should immediately links you to think about your dot product. Since PF is perpendicular to the line, PF dot with my direction of a line will give me 0. So by drawing out the diagram, it should do a trigger memory to help you to remember the fact that how to actually carry out these kind of things instead of pure memorizing. So let's quickly try on this question. So first, I'm going to let F denotes the foot of perpendicular from point P to line. Some school require to spell out foot of perpendicular, so please follow your school. Okay, so from here, take note that F actually lies on the line. So I can say that since F lies on the line, which means that F will fit in the criteria of R. Okay, and I can say that OF will essentially be equal to minus 1 plus lambda, 1 plus 2 lambda, 2 plus 2 lambda, for some lambda is real number. When I talk about for some lambda is real number, means that if I sub in a specific value of lambda, I will definitely be able to get OF. Okay, that's what the phrasing is trying to say here. Okay, from here, what I'm going to proceed on is, okay, I'm going to find my PF. Okay, PF, it will be equal to OF minus OP. And OF I already stated in terms of lambda on my previous part. Minus away OP, which is over here, is equal to 2, 2, and 4. Okay, if you do a quick calculation, it should derive as minus 3 plus lambda, minus 1 plus 2 lambda, and minus 2 plus 2 lambda. Okay, once you hit this stage, okay, I need to remember that PF is perpendicular to the line. So I can quickly say that since PF is perpendicular to my line, okay, I take PF dot with my direction of my line, which is 1, 2, and 2, I will get 0. Okay, this is my direction of my line. Okay, from here, I'm going to quickly expand out. I'll get minus 3 plus lambda, minus 2 plus 4 lambda, minus 4 plus 4 lambda, equal to 0. And do a quick calculation, you should derive as lambda is equal to 1. Okay, with this, you already found OF in terms of lambda over here. Okay, so I can quickly sub my lambda value back. So OF will be equal to minus 1 plus lambda, 1 plus 2 lambda, 2 plus 2 lambda. And because I know my lambda value, which is 1, I can essentially quickly derive OF to be equal to 0, 3, and 4. Okay, with this understanding, you can actually try the example over here, which I have given you a different kind of point and different line. You should be able to derive the foot of perpendicular to be minus 1, 1, and 4.